right, guys, so for asexual and sexual reproduction, we're going to go ahead and do a T-chart here. So for the asexual part, we have one parent. I think like if I have a pencil, I have one pencil. So asexual, one parent. It has a 100% of the DNA is going to come from that one parent. Therefore, the offspring is going to be identical. Not just look identical, but genetically identical because it is the same DNA. Because of that, it also takes less time. There's little to no raising of that offspring. Most of the time, a lot of these like bacteria reproduce asexually, and it's not like they go and they nurture the baby bacteria and they take them to school and they change their diaper. They come out as pretty much adults. Sometimes within 20 minutes later, they will be reproducing on their own. So asexual reproduction is very, very fast. It does have some disadvantages, though, because they're all identical. Versus sexual reproduction. We, as humans, reproduce asexually. Most animals reproduce asexually. What that means is that we have two parents. 50% of the DNA is going to come from mom and 50% DNA from dad. What that does is that it gives diverse, meaning different, offspring. I like to think about a litter of cats. If you've ever had a litter of cats, you will probably notice that most cats are very different. There'll be some black and white ones, some totally white ones, some totally black ones, maybe a gray one in there or an orange one. So different, they're very, very different. And that's good because just like you guys are, some of y'all are taller, some of y'all are shorter, some of y'all are, we have different color skin. We have, some of y'all might be good in math, others might be good in good athletes or in reading or science or whatever. So, and we bring our strengths at different areas of our, of our life. With sexual reproduction, typically it does take more time, not just in the belly, like for humans, 9 months, but also raising. We typically raise our young until they become adults, so it definitely is a lot of invested time as well. But we are able to survive different things. Like sometimes every year the flu kills a bunch of people, but have we ever gotten the flu and lived? Absolutely. So things that's definitely an advantage. As a good thing to be different because we're stronger in certain areas, and that doesn't wipe us all out. So, next thing, certain species of whiptail lizards have only female individuals and no males. So right there, that tells me already I'm probably looking asexually because no males. These lizards reproduce asexually, so I was right. What is one disadvantage? Disadvantage means something that is bad about asexual reproduction for these lizards. So a new population can be established by a single individual in a relatively short period of time. Well, that's actually probably a good thing. That would be what we would call an advantage, not a disadvantage. So it's not that one. All of the members of a population are genetically very similar. That's true. And less able to survive environmental changes. Typically, guys, environmental changes are things that hurt us, things that are bad. So if we're all the same, for instance, just kind of what I said before, if we get the flu, or if they get the flu and one of them is going to die, then it's going to kill them all. So this I like as a possible answer. They're smaller than lizards that reproduce sexually. Well, we don't know that. Nowhere in the thing did it say that. So they could actually be bigger. And they're more likely to develop a variety of tail lengths. They can't develop a variety of tail lengths because they're all the same. So they're all identical. So that's wrong. So the correct answer is definitely going to be B. All right, next question. The hydra is a very small, simple animal that lives in water. This is a hydra. They reproduce asexually by budding. Okay, budding, a process by which a bud breaks off of an adult hydra and floats away. So this picture right here, guys, this is the parent, this is the adult, and this right here is the offspring. what happens is that it is literally some little growth kind of grows off of it, and then it grows a little at a time, a little bit more. It will eventually detach itself, and it will look kind of just like the parent, and it will be 100% identical. So which of the following best describes a hydrobud? Well, we know it's asexual, so does it contain genetic material from two parents? No, one parent, so F is wrong. A hydrobud is genetically identical to the parent hydra. We like this one. It's identical, 100% of the DNA. A hydrobud has different mutations than the hydra parent. Again, no, it's identical. And the last one, a hydrobud has half as much genetic material as the parent hydra. Nope, it has 100%. So all of these are wrong. G is your correct answer.
Okay, folks, we had a little bit of technical difficulties here, so we're going to have to start over, so I apologize for that. Okay, so using formulas. Key thing here, obviously, use the right one. Make sure you use the right formula. There are, why is it doing this again? Are 3 formulas. Sorry, we're having technical difficulties with these pens. Always draw the triangles on the formula chart. Okay, like I was saying, draw the triangles on the formula chart, and let's go ahead and we're going to guide you through that. First formula that I want to talk about is speed is equal to distance divided by time. Anytime you're drawing your triangles, make sure that the right side of the equal sign has to be identical on the triangle. So for this formula, we have the D over the T, so that means the D has to be on top, and the S and the T have to be on the bottom. The second formula is force is equal to mass times acceleration. On this one, the M and the A are side by side to the right of the triangle, so M and A must be side by side. The F needs to go on top. And then, of course, the last one is density equals mass divided by volume. And the M and the V are on top. M is on top of the V, so on your triangle over here, the M is going to be on top, the V on the bottom, and the D for density is over here on the left. Okay, 4 students race toy cars on a track. The mass and acceleration of each car is recorded. So we're going to have mass, we're going to have acceleration, and the question of which toy car had the greatest force. So we're looking for a formula that has force, mass, and acceleration. If we go over to our formula chart, we should see where we have drawn force equals mass times acceleration. There are 3 formulas, and the unknown, what we're looking for, of course, is the force. So the formula would be force equals mass times acceleration, m times a. And what we need to do is do each of these and see which one has the greatest force. So we're going to multiply the mass times the acceleration to figure out the force for each of these. And the first one, 0.19 times 2 gives us 0.38, and force is measured in newtons. The second one, 0.15 times 3 gives us 0.45 newtons. The third one is 0.25 times 1.5, which is 0.375 newtons. And the last one, 0.21 times 2.5 is 0.525 newtons. Of course, the biggest one is that last one, 0.52 is bigger than the rest of them. So 4 is going to be our answer.
Okay, so here we have energy transformations. Energy transformations are going to be, there's a couple of different kinds. There's mechanical, and that always is having to do with movement. That's also, you might hear it as kinetic. Chemical. Chemical is a big one, guys. That is stored energy. That's there like a Like food is chemical energy. It's stored in that food until we eat it, and then our body uses it. Batteries are chemical energy. Gasoline, it's there until it gets used and burned up. So there's also thermal, so that has to do with heat. We have electrical, so that has anything to do usually with a plug. If you have to plug it in, it starts with electrical. There's radiant energy, which is sunlight. And then there's electromagnetic energy. We didn't see a lot of that. And then nuclear energy. All right, so here we have, let's see, hair dryer or flashlight. Would a hair dryer be electrical or chemical? So it does start with a plug, so this is going to be my flashlight. I'm sorry. Hair dryer is going to be electrical, and what part of that is mechanical? Well, once it turns on, it turns a little fan, and that fan sends out the thermal heat that dries your hair. The next is going to be chemical. That's going to be the flashlight. What part of the flashlight is chemical energy? Well, that's the battery that's in it. Okay, your phones have chemical energy as well. It has a little wire there that goes to, that's the wire part, the electrical, and then the light is going to be radiant. All right, first one, when a lion eats a zebra, and then uses the energy from the zebra to run, the lion's body converts. So what I said earlier, that zebra or anything that we eat is chemical energy. It's stored until our body uses it. So that's chemical energy, and then he uses that energy to run. Well, that's movement, and that movement is mechanical energy. So right here, these two are going to automatically be gone because this is the zebra right here. This is the chemical, and it changes, and this is the running. So our correct answer is A. It doesn't turn to a light unless he ate it and started glowing, which he did not. All right, the diagram below shows a hot air balloon rising. Propane gas tanks are seen at the bottom of the balloon. So propane gas tanks right here, this is chemical energy. Again, that's the gas. It's not stored in there until we release it through or by turning it on and lighting it up. That flame then is some sort of a heat energy, and then that causes all that energy to come up here. We know that heat rises, which causes movement, so a mechanical type energy. So here we have these two, the chemical to mechanical to thermal, or chemical to thermal. Yeah, so this is the gas, that is the heat, and that means that it's traveling up. So our correct answer is going to be D. All right, guys, so circulatory system, main arteries, main organs are going to be the heart, your veins, and arteries. Its function is to transport material, whether it be air, food, medicine. These are personal FedEx guys inside of our bodies. Our respiratory system, it's lungs, trachea, windpipe, it's our breathing. Its function is to exchange gases from oxygen to carbon dioxide and vice versa. Digestive system, main organs, stomach, small intestines, mouth, esophagus. There's many more, but these are the main ones. They break down food for energy using enzymes, saliva, stomach acids. Here the question says, when people run long distances, their muscles require increased amounts of oxygen. That's why we breathe fast. Which system is responsible for carrying this oxygen, keyword, to the muscles? Nervous system, that's our brain. Our brain doesn't carry anything other than messages to our brain. Respiratory system, this is breathing. So we do breathe a lot heavier, but digestive system, this is, breaking down food. We don't need that. Circulatory system, this transports material. What it does is it transports oxygen to our muscles that need it, or mitochondria. So our correct answer is going to be D, circulatory system.